Oh gosh. Hi. Hello. And welcome to Functions 2. Maleficent's excited to help out, right? Are you? Maybe. I don't know. We're going to spend a couple days on functions. We're going to talk about some basic things. Today is pretty much your happy functions book and piecewise functions. You all remember your happy function book, right? Right, Mel? You made a happy function book? Don't show them your butt. That's that's unsightly. All right, so getting going. Some basic things about functions. Functions, the idea is that you put one in, you get one out. That's the main thing. Domain is the thing that you put in. Range is the thing that you get back out. So domain, you want to watch out for things like zeros in the denominator. You don't want negatives and square roots, and logarithms can't take zero or negative, so only positive values. Range is the thing that it spits out, it's your Y values. You can remember that because it's alphabetical. Domain and range, input, output, X and Y, they all follow alphabetical and they all match up with each other very nicely. We did have a cool trick to decide if something was a function or not, and that's the vertical line test. So what we do is we take a vertical line and we drag it across our graph and see if there's ever a point where it touches the graph 2 times. So here's my cool vertical line. So you could use like a pencil or something. And you just drag it across your graph and see here where it's touching that red line twice. That means that thing is not a function, fails the vertical line test. You can do the same thing with this one. Now, there can be times where you have no graph at all, like in this one, where there's nothing here, but that's okay. It just can't touch it multiple times. So this one passes and this first one is not. So this one is not a function. This one is a function. The fancy way of saying that is y is a function of x. Here, y is not a function of x. Other things that we do with, we did this a little bit last time-ish. You saw the notation. There's function notation where you're putting particular things into a function. It's a way of writing shorthand for some of the more complicated things that we might be doing. So here we've got our function f of x, and we want to do this thing. So here where there's that f of x, it wants us to do all of what f of x is. It's 1 over the square root of x minus 1. Then there's a minus, and then it wants us to do this f of 2. So we're going to put a 2 in for x, or we're going to copy everything else. 1 over the square root of 2 minus 1. And then that whole thing is over just a regular old x minus 2. And we can work through and we could actually simplify this thing. Let's see, we've got, here, I'll do it down here. So 1 over square root of x minus 1 minus the square root of 2 minus 1. 2 minus 1 is 1. Square root is 1. And so that's just 1 over x minus 2. Come on, give me some more space here. Now I want to try to simplify this thing down. What I think I actually want to do is with that numerator, I want to put those together. Yeah, that's what I'm going to do. So I'm going to convert that 1. I'm going to, instead of this 1, I'm going to make it a square root of x minus 1 over a square root of x minus 1. See why in a sec. So this becomes, when we put those two things together, they're numerators. We get 1 minus the square root of x minus 1 over the square root of x minus 1. And now, since that's all my numerator, my denominator, that's really a divide by x minus 2, right? So instead of dividing by x minus 2, I can multiply by x minus 2. under a 1. Do the reciprocal, so multiply by reciprocal. And so we get 1 minus the square root of x minus 1. And we've got a square root of x minus 1. And these are all getting multiplied together. So now I can just multiply straight across. So my numerator is 1 minus the square root of x minus 1. Oh, I'm getting real sick of saying that. And then in our denominator, we have x minus 2 times the square root of x minus 1. I don't know why I put a parenthesis around that. But that's our simplified thing. Hey, neat, cool, all done. If you'd like to see an additional one, I'll do this one in the Moodle notes and you can see that. That one's actually a little bit simpler, but it's worth looking at if you would like to see another example of this. Next, we want to find the domain and range of our function algebraically, and we can use a graphing utility to double check it. So we're going to do it algebraically first. So again, with domain, you want to check for, is there an x in the denominator? No, so we don't have to worry about that. We also want to check for x's inside of square roots. Don't have to worry about that. Logarithms, nothing to worry about there. So those are the three things that you check algebraically for right now. So since none of those are true, our domain is all real numbers. So you can do negative infinity to infinity. Since there were no issues. Now, when we check our range, what we need to do is we need to get x by itself instead of y being by itself. So I want to solve that thing, that g of x acts as a y. So when we solve it, we get x equals, we'll have y. We have to get that 5 to the other side, so plus 5. And then we want to square root that whole thing. And we get plus or minus. Now we do have a concern this time because that y is inside of that square root. That y can't be negative, so we only can take positive values. So our range for this thing, the smallest number that we could put in there is negative 5. If we did negative 6, we'd get a negative in there. So we want to make sure that thing stays greater than 0. So our range is going to be negative 5 to infinity. If you really wanted to, you could solve the inequality y plus 5 is to be greater than or equal to 0. Or if you're cool, you can just do it in your head. Let's double check that on Desmos real fast. Hopefully I've got Desmos handy. No. Sorry for the delay. I'm in the way, but that's okay. So y equals, what is this, x squared plus 5. So here you can see on our graph that in terms of the domain, this way, our x values, there's no problems. But in terms of our range, we don't get anything until we reach 5. Was it minus 5 and not plus 5? It was minus 5. I think I wrote plus 5. Yeah, I wrote plus 5 there. That, I want plus 5. There we go. So in terms of our range, we don't get anything until negative 5. It doesn't go any lower than that. We can go really, really high, but it doesn't go lower than negative 5. Done. Okay. We're going to do a little bit of just finding the domain. I'm going to do that first one. So that one, we need to make sure that what is there is staying greater than or equal to 0. Now this one I can't really do in my head. I'm actually going to have to do a little calculations. Yep. So I need something that adds to be 2, multiplies to be 2, and adds to be 3. Well, that's easy. It's 2 and 3. So x minus 2 and then x minus 1 is greater than or equal to 0. Now, you might not remember this, but we did actually do this in pre-calculus. It was back in chapter 1. What we need to do is we need to check our critical points, so where x is equaling 0, and then we check each interval to see which ones are actually going to work in the equation. So we draw out a number line. We're concerned about 1, and we're concerned about 2. And we check each one of these spots to see if it works or not. So for example, 0. is a number that's less than 1. See if that works. So 0 minus 2, that's -2. 0 minus 1, that's 2. Is 2 greater than 0? Yeah. So that one works. Then we need something that's bigger than 2. So I'm gonna skip this one for a minute. Something that's bigger than 2, like 5. So 5 minus 2, that's 3. And then 5 minus 1, that's 4. And so that's 3 times 4, that's 12. That's bigger than 0. Yep, cool. So this part works. If we check something in the middle, say 1.5, we could actually use Desmos to check this out for us. Plus, I'm getting tired for the day, and I'm worried I'm going to get it wrong. So we check 1.5 minus 2 and 1.5 minus 1. Right? That's 2 minus 1. Great. And we get negative 2.5. Negative 2.5, that is not greater than 0. So there, it does not work. So we do not have anything right here. So this tells us what our domain is. It starts at negative infinity. So it's like, whoop. That part is good. We have a gap in the middle, and then we continue here. So negative infinity to 1, bracket. I use a bracket because I have an equal to right here. Union, bracket, to infinity. Done. If you'd like to see an additional example of this worked out, I'll be doing this one in the PDF notes. What's next? We're going to determine if y is a function of x. So really, this is a thing of just saying, hey, solve for y and see if anything funny happens. So in the first one, you can see something funny is going to happen right away. We got to square root both sides in order to get y by itself. And you all know what I do, well, what everybody should do. If you square root both sides, you get a plus or minus. So here we're taking our x and it's spitting out two values. A function, you put one in, you get one out. This one, you put in one and you get two out. That's no good. So this thing is not a function of x. So this one is no. In the second one, we still want to try to get y by itself, but it's a little bit more convoluted to solve. So I'm going to get rid of this x squared. It's not doing me any favors. So x squared y plus 4y equals x squared. Now I've got a common factor of y. Ooh, so I could factor that out. So I'm trying to get all the y's together in a sense. So x squared plus 4 equals x squared. Now all I need to do is I got to get rid of this thing. Well, that's really easy. There's this thing called division. So I can divide both sides by x squared plus 4. Nice. So get y equals x squared over x squared plus 4, which seems really wild, but the thing is, if you put in a number for x, it's only going to spit one thing back out at you. And if it's only going to spit one thing back out at you after you put one thing in, that is a function. Yes. If you don't believe me, you could also check this with its graph. Let's go to Desmos and graph that really fast. Another cool thing about Desmos is that you don't have to solve for y. Like if you do this on your graphing calculator, you have to solve for y in order to put it in. In Desmos, you can just type it in right as it is. So x squared y minus x squared plus 4y equals 0. Boom. Here, let me turn off this older graph. And there's our function. We did it. And you can see if you dragged a vertical line across that graph, there's not going to be any issues. You're only ever going to touch that graph once. So, and even as it gets bigger out, it's just kind of a flat line with this goofy little goop in the middle. All right, what's next? Happy function. So you should have all of this information in your happy function book. Maybe you want to throw in trigonomic functions, because when we did our happy function book, our trig functions weren't in there, but all these other ones were in there. The thing I do want to talk about, though, is piecewise functions. Another thing that might have been in your happy function book is I had you write down this table. Let's add something to that: domain and range changes. This is something that you can tack on to kind of give you a little bit more information. The flips, it's going to vary what it's going to do to the domain and range, so you can't really say for sure. But in terms of these moves and the stretches and shrinks, they don't do anything. They'll never do anything. But the moves, this will tell you what's going to happen to the domain or range of a function after you do that transformation to the function. So you can copy that down. You don't necessarily need to. You can pause the video if you need. So here's our graph. I recognize that as a quadratic, and I want to describe the transformation. So that's a quadratic that's been shifted down 1 unit. I can see here there's -2. So this vertex has gone down 1 unit, and it's gone 2 to the right. So I would say down 1 unit, and then shifted right 2 units. So if we wanted to write that function, it would be x squared. And I'm going to leave a parentheses because there's going to be stuff going on the inside. Now, the inside is our left and right shifts, but it's all backwards and weird. We would think right would be a positive move, but right is actually minus. If we want to move up and down, that's happening outside of our function. So this one's going down 1 unit, and this one follows a more sensible fashion. If it goes down, you subtract, goes up, you add. All right, now on to piecewise functions. Now we talked about these a little bit, but the idea is that depending upon what your number is that you're going to put in, you're going to do different things to it. If x is a value that's bigger than 2, it's just 5. It spits out 5 every time. If it is between -2 and 1, then the function wants to square it. If the x value is less than -2, then we're going to multiply it by -3. Think about it as a function that can't really decide what it wants to do. It changes its mind as the x value changes. So here's a piecewise function. So we want to figure out what its values are going to be for these different inputs. So here, if we want to do f of -1, I want to say, okay, well, is -1, is that less than 0? Yeah, it is. So I want to do this top thing, and I'm not going to do the bottom thing. So I'm going to do 2 times -1 plus 1, which is -2 plus 1, so it's -1. So f of -1 is -1. Then we do 0. Is 0 less than 0? No, it's not. Is 0 greater than or equal to 0? Yeah, it is. So we want to do this bottom thing. We're going to do, here, I'm going to change colors. We're going to do 2 times 0 plus 2. So that's 2. Cool. Next, we got f of 2. Is 2 less than 0? No. Is 2 greater than or equal to 0? Yes. So I want to do this bottom thing again. So we're going to do 2 times 2 plus 2. So that's 4 plus 2 is 6. Sweet. All right. Now this one's sneaky. So we've got t squared plus 1. T squared plus 1, is that less than 0? Well, basically this question is asking me, is it positive or is it negative or is it positive? Well, I know that t squared, if you square something, it's always positive. Like if you square a negative, it's positive. If you square a positive, it's positive. So I know this is a positive value, and then I'm making it bigger. So it is a positive value. It is bigger than 1 because it's been plus 1. So I know whatever this happens to be, it's got to be positive. So I'm going to do the second thing. If you need to hear that explanation again, you might want to rewind the video. So we're going to do 2 times t squared plus 1, and then we're going to plus 2. So this turns out to be 2t squared plus 2 plus 2, which is 2t squared plus 4. Neat. A little sneaky there on that end one. Never know what you got to think about in calculus. So there's another sneaky one here, but I will do these in the PDF notes if you wanted to check those out there. But you want to kind of have that same idea. This is a positive one. I know it's getting bigger by 1. The smallest it could be, it's going to end up being the second one again. All right, now I want to draw the graph of a function. Now, when you want to graph these things, the best way to do it is to graph it as if it was just a regular old function and then erase what you don't need. So if I wanted to graph this thing, I want to start at 3. 1, 2, 3. And my slope is -1, so I know I'm going to be going down 1 over 1. So I'm going to have a line kind of like this. There's my rough graph. Now I'm going to say, hey, x has to be less than or equal to 1. So it's going to be cut off at about right here. I don't know why I'm using my mouse to draw this. But at that point, that's kind of the cutoff point. I only want this piece of it. I don't want this piece of it. So I can erase this much of my function. So that's the first part. Now I want to do the second part. For the second part, I want to do 2x. So it's going to have a start at 2. I'm sorry, a start at the origin, and has a slope of 2. So it's going to go up 2 over 1. So it's going to go here as well. And then up 2 more, like, and over 1 more. So it's got a line like that. Now this one I only want it when it is when 1 is less than x, or more simply, when x is greater than 1. So in this one, I want it when x is greater than 1. I don't want it when x is less than 1. So I don't want this piece of the red line. No. There we go. So there's our piecewise function. So it goes down here and then shoots up suddenly. Now, one thing to keep in mind is these equal tos and less thans. In terms of the red function, it's open right here because it's got a less than, not an equal to. But in terms of the brown function, it's filled in because the brown function has has an equal to, so it gets a filled in circle. Since they're right on top of each other, we are going to keep it filled in. But if they were separated, because they don't have to be connected, then we want to have an open circle for the red and a filled in circle for the brown. Next, we want to find its domain. So when we're checking our domain, we see if there's any problems where we wouldn't know where to put our x's. We know where to put everything that's less than 1. We know where to put everything that's bigger than 1, and we know where to put 1. So we don't have any problems for our domain. It's going to be -infinity to infinity. Our range, however, does have a problem. You can see that this thing never goes below this point right here. That's as low as it goes. It goes up and up and up, but it never goes lower than that. So our range does have some issue. Our range, our lowest point is 1, because we're checking our y values for that, and it goes up to infinity. If you'd like to see another one of these, we'll be doing this one in the PDF notes, and I'll have that all worked out for you, and I'll probably make a better graph because my graph was pretty gross in that last one. All right, now our last problem of the day, we're going to write our own piecewise function. We can see we've got 1, 2, 3 pieces to this piecewise function. We're going to write an equation for each one and then determine what the intervals are for each piece. So we've got f of x, and we're going to have 3 pieces to it. Our first one is right here. Actually, I'm going to start with this one because it's really easy. It's just a y equals the same number over and over and over again. It's y equals -1, because it's just a flat line. Next, I'm going to do this one. Well, no, let's do this one. Let's do this one next. So it's got a y-intercept at 2, so I know it's going to be +2. And if I can get a slope, I've got point slope form, and I can totally get a slope. It's going down 1, 2, and over 1. So its slope is -2. Finally, we've got this one. It has a y-intercept at 0, so I don't have to write anything. But what's its slope? It seems to be going up 1 and over 2. So it has a slope of 1/2 and an x. And I'd write +0, but there's no real reason to do it because our y-intercept is at 0. Next, we're going to check our intervals for each one of these pieces. Now the first one, here, let's do this one first. We'll do it in reverse order again. So that one is between 1 and 3 in terms of our x values. So it's between 1 and 3. X is between these two. Now at 1, we have an open circle, and at 3, we have a filled in circle. So we're going to have an equal to at 3. Our next one is between 0 and 1. At 0, we have an open circle, so we're going to leave it without an equal to. But at 1, we have a filled in circle, so we want an equal to. Do that one more time. Our last one is between -2 and 0. Both of them are filled in. Since both of them are filled in, we're going to give both of them equal to's. And that's it. I think, I'm pretty sure. I think that's enough. So basic things about functions is if you've got a function, you put one in, you get one out. For your domain, that's everything that you put in. Watch out for no negatives and square roots and no zeros in your denominator. Your range is everything that comes out, and they often will match with any sort of issues you've got with domain. Make sure you've got your happy function book and that transformations table, because that's really, really important. And then piecewise functions is that kind of slightly new thing that we talked about for today. You're at your at this point, after you're done with today, this is the halfway point for videos. So congratulations on getting like halfway through the lessons for our boot camp. Bye-bye.